All right, welcome back. Now we're going to be looking at what happens when we put two lines, so a system, right? That's linear, so a linear system on the same grid at the same time. We're going to see what happens. So basically, we're graphing one line on the grid, doing your basic graphing techniques, and then we're graphing a second line on the same grid. And we're actually looking for where they touch, if they touch at all. That's called the solution to the system. So that's why we're being asked to solve the system. Solving means we're looking for that point of intersection where these two lines will happen to touch. So you need a straight edge to make sure that your lines are super straight in order to give us an accurate answer. So the first way of graphing lines that you probably remember from before is called the table of values, right? So we need a separate table, one for each line. Now the first equation we're given is 2x plus y equals 5. Now right away, that's hard for us to get the equation on the line because it's not written in y equals mx plus b. We want the y by itself. So in order to get the y alone, what we need to do is kick out the 2x to the other side of the equation. So I'm going to rewrite this with the y now sitting all alone. And joining the 5 on the other side is going to be the 2x. But when the 2x crosses the equal sign, he's going to now become negative or subtract. The plus 5 is still plus 5. So make sure that you don't put the 5 as negative and the 2x as positive. So that's what I'm going to put up here in the second column of the table to help me determine the y's that are going to go with the x's. Now remember, in a table of values, you're the one that gets to pick out what are your x's and y's that you use. So I'm just going to create a few more rows here. So I'm going to cut this up into a couple more. 1, 2, 3, 4, 5. Yeah, we typically like 5 points in order to make our lines very accurate. And the points we tend to sub in are the ones in the center of the grid. There's no point in subbing in 10 and 15 because our x-axis doesn't even go that far. It's cut off here. So let's go with like -2, -1, 0, 1, and 2. So easy numbers to sub in. -2, -1, 0, 1, and 2. So remember that in a table of values method, the x's come out of your head. You can sub in any x's you want. We could have subbed in -5, +23, -50, but there's no point if they're not even going to be graphable. Now what's going to happen is we're going to independently sub in each one of these into our equation to solve for y. So we're going to do BEDMAS. -2 times the -2 that is now going to be x, and we're going to add 5. Multiply before you add. 4 plus 5, we're going to get 9 out of that guy. Next one, we're going to sub in -1 where we see the letter x. So -2 times -1, add 5. -2 times -1 is +2. +2 plus 5 is 7. Then we're going to sub in 0. Now we should already know that this is now the y-intercept, right? Whenever x is 0, whatever's left is the y-intercept. So it should actually work out to be 5. -2 times 0 is 0. 0 plus 5 is 5. So that's where this line starts on the y-axis. Then we're going to sub in 1. -2 times 1 is -2. 5 take away 2 is 3. And -2 times +2 plus 5. Now, if you're noticing, first answer was 9, then it became 7, then it became 5. There's a pattern here, right? First differences. -2, -2, -2, -2 more. I should already know what this answer is going to be. Let's just check. -2 times 2 is -4. -4 plus 5 is in fact 1. 3 minus 2 is 1. So what this gives us is our points. So what does this mean? -2 comma 9 is a point on this line. -1 comma 7 is a point on this line. 0 comma 5 is a point on the line. 1 comma 3 is a point on the line, and 2 comma 1 is a point on the line. So you're going to go to -2 comma 9, so -2 on the x, comma 9, around there. -1 comma 7, there. 0 comma 5 is there. 1 and 3, and 2 and 1. So again, with a straight edge, making sure you're super accurate. Make your line nice and long. Arrows on both ends because the line keeps going and going and going forever, right? Just because I stop drawing it doesn't mean that it stops. And we're going to label it. You could either label it with this first version of the equation, or you could label it with the y equals mx plus b version. It won't matter. They're the same line. Now let's figure out the second guy, because that's not a system yet, right? That's just a single line. So in this next one, it's already in y equals mx plus b form, so we didn't have to rearrange it. We're going to sub in the same numbers one at a time. So 2/3 times -2 minus 3. So top times top is -4/3, right? Top, bottom times bottom, 3 times 1 is 3, and we're going to minus 3. So if you want to use your calculator, go ahead. 3/1 becomes -4/3 minus 9/3, and that's going to be -13/3. Now that may not make a lot of sense to you, where to graph -13/3, but you can change it into a decimal, and this is -4.333333. Okay, so -4.3 repeating. If you want to think of it as an actual location, where are you going to find that point? The next one should be a little easier, hopefully. 2/3, sub in -1, and then we got a minus 3. So this is -2/3, right? Positive times negative is negative. Put the 3 on the bottom. Minus 3/1. Remember, there's a 1 there. Top and bottom, got to times the second fraction by 3 in order to subtract. So -2/3 minus 9/3 is -11/3. So again, if you want in your calculator, go 11 divided by 3, and that'll give you your decimal for that. So that's almost -4, but not quite. -3 point, I think, 6666666. Let's sub in 0. This one will be super easy. Top times top is 0. 0 minus 3 is just -3. We knew that already was the y-intercept. So 0 minus 3 is a point on that graph. Let's sub in 1. 2/3 times 1 minus 3. Top times top, bottom times bottom is 2/3 minus 3. Again, 2 take away 9/3. When I get a common denominator is -7/3. So that's -2 1/3. And let's sub in 2. 2/3 times 2/1 minus 3 is 4/3 minus 3 is 4/3 minus 9/3. Again, top and bottom times 3 to make the bottoms match. And 4 minus 9 is -5/3, which is -1.666666. So you can change these into decimals if the fractions are bothering you, so you know where to put them on your graph. So now let's actually plot these points. So the first one again, -2 on the x, -2 on the x, -4 and a bit. So again, you're kind of estimating. It's not going to be perfect. -1 on the x, -3.66666666. So I'm just estimating that it's about there, underneath the -1. 0, -3 is a good point. 1 and -2 1/3, so just underneath the -2 number. And 2 goes with -1.666666. And you can see that the dots still fall in a line, right? They shouldn't be far off from each other. And attach, and let's see what we're looking at. Arrows and label. Y equals 2/3 x minus 3. So it looks like let's see. Could it be 3 and -1? Could it be that they touch at 3 and -1? So if I think that that was supposed to be where they were touching, and it's just the fact that the lines weren't accurate, how would I be able to know that 3, -1, 3, -1 is where they're supposed to be touching? Well, the way I can test again is by subbing in 3 into the first equation for x and subbing in 3 into the second equation for x and checking to see if they equal -1. So let's try this. -2 times 3 is -6. -6 plus 5 is -1. So this point is on the first line. So this line here, this purple line, is actually supposed to be a little bit over. In the second equation, if I sub in 3, like I said, for x, when you sub in 3 here, 2 times 3 is 6. 6 divided by 3 is 2. 2 take away 3 is -1. So this point is where they actually touch. So it's actually supposed to be here. That is the point of intersection. So my green line is a little bit off just because I'm guessing of all the decimals. So the point of intersection, which we short form as POI, point of intersection, is 3, -1. It's not some decimal that's in between. It's actually a nice point that works. So normally the lines where they touch, it's more obvious than what you saw here. This one was more of a difficult one to see. Now, we don't have to use a table of values. As you can see, that method always works. It's always a good method if you're stuck. However, there are quicker methods in order to graph our lines if we're looking to see where they touch. And this method is called X and Y intercepts. So using X and Y intercepts means that I'm trying to solve for where this first line touches the x-axis and touches the y-axis. And I'm going to plot those 2 points, and then I'm going to attach. That gives me the first line. Then I'm going to repeat. Where does the second line touch the x-axis? Where does the second line touch the y-axis? I'm going to plot those 2 points for that line, and then I'm going to attach, and then I'm going to look at my picture. Okay, so we deal with each line separately. Let's do the 3x plus 2y equals 6 line. And I'm going to say, you have to tell the reader what it is you're doing. So for the x-intercept, comma, remember, anywhere on the x-axis, y is worth 0. So this is -4, 0, -1, 0, 3, 0, 7, 0. Anywhere you are on the x-axis, y is always going to take on the number 0. So that's why we're looking for that particular point, because we already know what the other letter has to be worth. So 3x plus 2 times y becomes 2 times 0. Now we're obviously going to solve for x. Anything times 0 is 0. That whole thing goes away. So it's just 3x equals 6. That's all that's left over. And divide both sides by 3 to isolate x. X equals 2. Well, that's great. That means he touches the x-axis. The x-intercept, right, is at the number +2. That is the point 2, 0. 2 for x, 0 for y. That's where he touches. But we need another point in order to attach to him to make it a line. So we find the y-intercept. So where does he touch on the y-axis? Where does he cross? For the y-intercept, comma, let x now equal 0, because anywhere on this y-axis, this is -8 on the y-axis, for instance, all the way down here, but the x value down here is 0. So 0, -8, 0, -2, 0, 5. So now we go back to the same equation, start again, but where you see the letter x, it is now going to become the number 0. And of course, anything times 0 goes away. So we're left with 2y equals 6, divide by 2, divide by 2, right? So you get 1y is worth 3. So this guy touches at +3 on the y-axis. There are your 2 points to attach to make a line. So we know that that point coordinates would be 0 on the x, 3 on the y. So with a straight edge, nice and long, there's your first line. So this is the 3x plus 2y equals 6 line. So that's standard form, graphing very quickly without having to do a table. All we needed to do was find 2 points, one on the x-axis, one on the y-axis, to attach to make our line, and we're done. So it saves you some time not having to do individual points more than these two. Let's try now the second line. So we repeat the whole process again. X minus 2y equals 10, right? That's the second line equation. Again, start over. For the x-intercept, and I'm going to short form it to int, period, comma, let y be 0. So when I say b, I mean equals. So mathematically, you would write y equals 0. Go to his equation, x minus 2 times 0 equals 10. Anything times 0 goes away. Look at that, x equals 10. So this is the point, 10 for x, 0 for y. So don't attach these two together. These are on separate lines. These guys have nothing to do with each other. We're now starting a whole separate line. So we have to do 9, 10, so approximately here, 10, 0 if we extended the x-axis. This would be 9, assuming that would be roughly 10. Now let's do the y-intercept that we're going to attach to this 10, 0 point. So for the y-intercept, I'll short form it to int, period, let the other letter, so x now, equals 0. So 0 minus 2y equals 10. So negative 2y equals 10 is what you're left with. Divide by negative 2, divide by negative 2. Doesn't switch signs when you're dividing. Negative goes away, 2 goes away, leaving you with negative 5. So this is 0 on the x, negative 5 on the y. 0 on the x, negative 5 on the y, which is down here. So I need to attach these two guys to each other. Nice and long and straight. Arrows, label, x minus 2y equals 10. And what I'm looking for is to see, do they touch? And if they touch, where do they touch? So it looks like 4, negative 3. That's the point of intersection, meaning the solution to the system. It looks like 4 on the x, negative 3 on the y. That's what it looks like. And again, the way we can test or try is sub in 4 for x, sub in negative 3 for y, and see if it works. Sub in 4 for x, sub in negative 3 for y, see if it works. So let's just quickly do that in our head just to test. 3 times 4 is 12. 2 times negative 3 is negative 6. 12 take away 6 is 6. So this point is on the first line. Let's see if it's also on the second line at the same time. X is 4, so that would just be 4. Negative 2 times negative 3 is positive 6. 4 in the front plus 6 is in fact 10. So that also works now for the second line. Left side equals right side. So if this point works for the first line and this point works for the second line, that means both lines must be at the same place at the same time. So therefore, that must be their common point. So that's the point of intersection. So that is the solution to the system. It says solve the system. Therefore, the solution to the system is 4, negative 3. And we should have done that more officially up here for. Therefore, the solution, because it did say solve in the statement, the solution to this system is 3, negative 1. So I'm just repeating my answers in my therefore statement. You could also say the POI, the point of intersection, is. That's what the solution refers to. So we've just done table of values and we've just done X and Y intercepts. So those were two methods to use to graph. Now you spent most of your time last year learning slope Y-intercept form, which I call the quick way of graphing. So in order to do slope Y-intercept form, you have to have the equation in y equals mx plus b. So find the slope in the Y-intercept, so which means put in y equals mx plus b form. So if you get an equation that comes in standard form, which are both of these, you're not going to be able to see what the slope is and what the y-intercept is right away just by looking. So you have to rearrange it. And what we're trying to do again is get the y on one side of the equal sign by himself. So 2y in this case is going to stay. I'm going to kick out the 3x to the other side. So he's going to become minus 3x. The 9 wasn't moved, so he's still plus 9. Don't change him all of a sudden. You could still write the 9 in the front. 9 minus 3x is also okay. But this is what 2y's are worth. I don't want 2y, so I divide by 2, divide by 2, divide by 2. The 2's go away in the front, leaving me with a single y. That's what I wanted. 3 over 2 doesn't reduce, so it's just 3 over 2. 9 over 2 doesn't reduce, so it's just 9 over 2. So this is negative 1.5x plus 4.5. That's what this looks like as a decimal. Okay, so if the fractions bother you, this is the exact same statement. So you would go to 4.5 on the y-axis, and here you would drop 3, run 2, drop 3, run 2. So the slope equals the number in front of the x, negative 3 over 2. The y-intercept is worth 9 over 2, right? The constant in the back. Let's try the next one. Now in this case, you see how the number in front of the y is negative? You're probably going to want him to be positive. So I'm going to show you that you don't have to kick out the 2x. You don't always have to kick out the x part. In this case, I'm going to kick out the y and put him on this side of the equal sign, so he becomes plus 5y. It's just what I'm going to decide to do. Now the 20 doesn't have a y with it, so I'm going to make sure the 20 now moves to the other side, joining the 2x to become minus 20. So now do you see how the y's are positive and the 2x is still positive? So some people prefer working with positives. So just be aware that you have options as to which side you move things. I still have to divide by 5, divide by 5, divide by 5. Everybody's got to be divided by 5 to get me 1y. 2 over 5 is just 2 over 5. 20 divides nicely by 5 though, right? 5 fits into 24 times. So remember that this is the same thing as this. The y can be on this side, 2/5 x minus 4 on the other side. So again, my slope is the 2 over 5 part, and my y-intercept is the negative 4. Okay, so it wouldn't have mattered if you had kept the x's on the left. I mean the y's on the left. So now that we've reviewed how to rearrange and get y by himself, let's actually use that in order to graph both of these the quick way using slope y-intercept form. So let's look at our first equation. So I'm just going to pull them out over here. 3x plus y equals 5. Is he in y equals mx plus b form? The answer is no. I don't have the y by himself. Now because there's no number in front of the y, I'm just going to keep the y where he is. I'm going to keep the 5 where he is. I'm going to decide to move the 3x. So it's going to become minus 3x, still plus 5. So my slope and my y-intercept is all I care about. The slope is the number in front of the x. It's always a fraction. It's negative 3 on top of a secret one that nobody writes. The y-intercept in the back is my 5, which means I start at 5. That's my starting point, right? 0, 5 on the y-axis. And I drop 3 and I run 1. Now, why did I say drop? Because of the minus. In the end, my line should look like this. It should be going down, just like my pen is. So let's try this. Start at number 5. There he is on the y-axis, but that's all I need that point for. It's not useful anymore. Drop 3, run 1. So go down 3 numbers, 1, 2, 3, run 1. Check. If I attach these, am I going to get a negative slope? Yes, so it must be doing it right. Continue though, just to get some more points. Drop 3 again. 1, 2, 3, run 1. Drop 3 again, run 1. Until you feel confident that you have enough points to give yourself an accurate line. Because remember, we're basing our answer on what our graph is giving us. So it needs to be accurate. Nice and long, and your equation. It doesn't matter, like I said, if you use the original version or the rearranged version. Whatever you want to call your line. Just make sure that you put a nice label on it towards one of the ends. All right, the second one needs to be rearranged though. We have negative x plus 3y equals negative 15. Again, the 3 is positive in front of the y, so I'm going to keep the y's on this side, and I'm going to make the negative x go over and join the minus 15. Now, when negative x travels, he becomes positive x. The 15 is still negative. Divide by 3, divide by 3, divide by 3. 3's go away here, leaving me with a single y. So, x over 3 is the same as 1 over 3 next to the x, but 3 fits into 15 nicely. So I'm not going to leave 15 on top of a 3. He goes in nicely 5 times. So again, my slope is the number in front of the x. So I'm going to rise 1, run 3. My y-intercept is this constant at the back, which is minus 5. 0, negative 5 is my y-intercept. So go to your y-intercept on the y-axis, 0, negative 5 down here, and that's all I need him for. Then I'm going to go up 1 over 3, up 1 over 3. So in the end, my line should look like this because it's a positive slope. So up 1 over 3. Well, right there. Up 1 over 3. 1, 2, 3. There. And you keep going until, again, you feel confident. There we go. I saw the point of intersection right away, so I'm pretty confident we did this right. And again, you label him with whichever version of his name you want to give him. Arrows, label. Now, do you see where they touch? I do. Happens to be right there. So that is the answer to this question. Where do these two lines touch? What is the solution to the system? The solution is 3 on the x, negative 4 on the y. That is our POI, point of intersection. Therefore, the point of intersection is 3, negative 4. And again, if you were to sub in 3 for x and negative 4 for y into each equation and check to see that left side is balanced with right side, it should work. And again, here's another testing situation. Last question. Determine whether or not negative 3, 2 is a solution to the system. So we don't have to graph and check. So again, your options are graph and look, or sub in point to each line to check that left side does in fact equal the right side. So we can do this algebraically or we could do this graphically. Let's do this algebraically because we've done enough graphing already. So line 1, 3x plus 2y equals negative 5. So just copy exactly the way it looks, the left side and the right side. We make like a table. The left side is anything to the left of the equal sign. So the left side is worth the 3x plus 2y part. In place of x, we're going to put negative 3. In place of y, you're going to put the number 2. In the front, we get negative 9. In the back, we add 4. That gives us negative 5. The right side, look at that, is negative 5. Left side equals right side. They're equal to each other, right? So it worked out to be balanced. Let's try the second line. So all this proves so far is that this point is on the first line, but it also has to be on the second line in order for them to touch at that location. So left side, right side, table, organized, equal sign in the front, negative x plus y is on this side, on the right side it's just a 4. Again, in place of x, you're going to put negative 3. Now watch this. The negative sign is part of the equation. This negative sign is part of the 3. So you're going to get a negative, negative 3. You're going to get a negative, negative. And then plus y is plus 2. So negative, negative makes positive. So you're going to get positive 3 in front, plus 2, That's 5. 5 does not equal 4. 5 and 4 are not the same answer. So what this showed is that this point is on the first line, but this point is not on the second line, right? So it worked for this guy, but it didn't work for this guy. So he can't be, this point cannot be a solution. It can't be the point of intersection because the second line isn't there in order to be touched there. So no, -3, 2 is not the solution to this system. So these lines touch somewhere else, not at that particular point. Okay, so that's the way you would test it algebraically by subbing in and doing this left side, right side table sub-in method. All right, until next time, have a good day.